Hello, and welcome back to the Elon Musk Signal channel. Imagine what it would be like if you were in the sky and wished right now we were on the ground. It would be terrifying, wouldn't it? At least the astronauts on the first spaceflight on the Starliner spacecraft didn't have to experience this feeling. The flight was postponed. It's really disappointing. But at least they are still safe. So, what really happened with the first flight of Starliner? What are the loopholes in the entire program? Let's explore in today's video. Less than a month after the first delay, the dream of the Starliner cruise spaceflight shattered again. They were strapped into their seats, ready for the historic moment when the rocket suddenly couldn't continue. This time, the issue wasn't with the Starliner itself but with the launch preparation system. ULA CEO Tory Bruno, the manufacturer of the Atlas V rocket, said the problem on Saturday, June 1st, involved one of the three network computer rack support structures at the launch pad. Each rack contains multiple systems, including identical circuit boards, all functioning as a ground launch sequencer (GLS), responsible for controlling the final steps in the countdown process. The GLS computer controls events such as umbilical cord retraction and bolt release to free the rocket from the launch pad. All three GLS systems need to be fully synchronized for the countdown to proceed. The issue was with one of the three circuit boards of the GLS system operating slower than expected to synchronize with the other two boards. This slight delay was enough to trigger an automatic halt feature at T-3 minutes 50 seconds. When the halt command is activated, the entire launch process has to be aborted. This is because rocket launches to the International Space Station are timed precisely to take advantage of the Earth's rotation, aligning the launch pad directly with the station's orbit. This factor is crucial for the rocket to rendezvous with a target moving at nearly 5 kilometers per second. Any unplanned delay in the countdown process for such missions would result in a minimum 24-hour launch delay. NASA and Boeing are working to resolve the issue and are aiming for a new launch date around midweek. This is a significant setback, delaying the Starliner cruise dream of spaceflight once again. This incident also raises concerns about the stability and readiness of the Starliner spacecraft for the big mission. To address the issue, engineers plan to conduct a comprehensive check after draining all the liquid hydrogen and oxygen fuel from the Atlas V rocket, while accessing the computer room. The next steps depend on accurately identifying the error, replacing, and testing any suspect components. Initially, NASA planned to restart the Starliner on the very next day, June 2nd. However, things didn't go according to plan. NASA later announced that the team would skip the Sunday launch opportunity to allow more time for engineers to address the computer issue. Finally, a new launch schedule has been set for the Starliner's first test flight, including the rendezvous and docking mission with the International Space Station. The launch schedule depends on the station's orbit and Starliner's rendezvous capability. The next two launch opportunities are on Wednesday at 10:52 a.m. and Thursday at 10:29 a.m. Eastern Time. The first flight of Starliner not only encountered setbacks due to the countdown issue, delaying the June 1st launch, but also revealed a series of serious technical and preparation deficiencies. In addition to the countdown glitch, mission managers faced several other issues. Software glitches caused a problem with the fuel loading valve on the Centaur upper stage of the Atlas V rocket, fortunately resolved by the backup system 15 minutes before the scheduled launch. The gas circulation fan in the astronaut's suit also malfunctioned but was addressed by restarting the system. However, the most serious malfunction came from the International Space Station. The water processing pump on the station experienced an unexpected problem, forcing the crew to store urine in bags and containers. This led NASA to change the payload for the Starliner by sending a replacement container weighing 70 kilograms into Boeing's cargo compartment to ensure proper mass distribution. Additionally, two suitcases containing clothes and personal hygiene items for astronauts Wilmore and Williams were also removed from the cargo list. They will have to use the station's common supply. The reason backup systems exist is to deal with situations like this. However, another concerning issue, unrelated to the recent delays, was discovered on the suborbital flight of Jeff Bezos' Blue Origin New Shepard spacecraft on May 19. During landing, one of the three parachutes of this spacecraft failed to fully deploy. Fortunately, there were no casualties in Blue Origin's incident. But the worrying aspect is that the Starliner's parachute system uses a similar design. Boeing engineers reviewed all test data and confirmed that the Starliner's parachute system had been successfully tested 160 times. This information provides reassurance to the engineering team and affirms the reliability of the Starliner's parachute system. The long-awaited Starliner test flight was supposed to be the first launch of the Atlas V rocket carrying humans since Gordon Cooper's flight 61 years ago, marking a historic milestone for the U.S. aerospace industry. However, it's noteworthy that Starliner is lagging behind its competitor SpaceX. SpaceX's Crew Dragon spacecraft, with lower costs, has successfully completed 13 flights, carrying 50 astronauts into orbit, including 12 crew missions to the International Space Station since its first test flight in May 2020. Years of delays and a series of technical issues have cost Boeing about $1.4 billion to rectify. Earlier, NASA aimed to launch Starliner into orbit on May 6, but the launch plan was postponed when United Launch Alliance engineers discovered an issue with the pressure relief valve on the center upper stage of the Atlas V rocket. The rocket was then removed from the launch pad and returned to United Launch Alliance's vertical integration facility. Although the pressure relief valve on the center upper stage was quickly replaced, Boeing engineers found a small helium gas leak in the Starliner's propulsion system. The leak location was identified at a heli gas conduit fitting for a specific RCS thruster component in the Starliner's service module. The leak was described as very small, but engineers needed to ensure it didn't become more severe during flight, affecting other RCS thrusters. After thorough analysis and testing, the mission management team concluded that the spacecraft could be safely launched even if the leak rate increased 100 times from the initial observation level, as it posed no danger to the crew or mission. Fortunately, the leak rate remained within acceptable limits. However, Boeing might face embarrassment if they stick to the launch plan on the same day as SpaceX. The launch ceremony for SpaceX's massive Starship rocket is also scheduled for June 6. According to the newly announced schedule, if both SpaceX and Boeing missions proceed smoothly, this will indeed be a highly anticipated moment. Continuous technical glitches, albeit resolved, still raise concerns about the safety and reliability of Starliner. Can Starliner complete its test mission this week and prove its competitiveness with SpaceX? Can Starliner overcome its shortcomings and fulfill missions in the near future? Let's wait and see. We will update you as soon as we have the latest information. Thank you for watching the entire video. Please leave your comments on today's broadcast. We greatly appreciate your feedback to improve our content. Don't forget to like, share the video, and subscribe to the channel for continuous updates on interesting information. Goodbye and see you in the next video.